I just uploaded this file. Do you hear me?
Yes, teacher.
Okay, I just uploaded this file. This is your textbook. In here you can see that chapter 4, chapter 5, chapter 6, chapter 7, 8, 9 of this book related to foundation analysis. So I'm not just gonna I'm just gonna talk about these chapters. If you remember, I talked about the general concept of foundation. As I said, the foundation is a last part of the structure. If you remember, I told you that. Here you can see that the structure is like this, and any structure. What?
Excuse me, sir.
What?
I just wanted to say, sir, even if you record on the phone, you can't even open the video of in the Teams.
What? If when I record, what should I do?
No, I mean even if you record in the Teams when you're using the phone, even if we had internet, I think it's because of the new update. We can't. The recording doesn't show there.
Okay, that's all I can do right now. Can you see the uh, my screen now?
Yes, sir.
Okay, that's enough. Anyway, um, I was talking about the general concept of foundation. If you remember, I told you we have different loadings uh, on the structure: gravitational loads, lateral loads, wind loads, whatever. And all these loads should pass this pathway and reach to foundation. And the function of the foundation is transmit the force to the ground. The safe part is the ground. The rest of it uh, belongs to soil engineering, soil and foundation engineering. So the foundation itself is a concrete element. Is a concrete element that you have to design it using structural analysis. For example, you have to know the capacity of the concrete or the reinforcement, all of that. So we consider this foundation as a box, okay, as a black box, and I'm not gonna go through this foundation, okay. All we should learn here in this course is about the soil below this foundation, okay. So the foundation, as I said, mainly in 99% is a concrete element, and you saw it in different situations. We have different types of foundation. If you have, uh, if you have, if you can satisfy the required spacing between the foundations, you can use uh, single or isolated foundation. If not, you have to use mats or strip or whatever. It's obvious. It's obvious that when you use two single foundation, this is plan view or top view. Okay. For example, this is your column, and this is the another column. It is obvious, as I said, if you can satisfy the spacing between these two foundations, it's better to use two isolated foundation. If not, you have to provide another system with this. Why this one is better? Case one is better than case two. It's obvious because in this case, you consume a less amount of concrete, and it's more economic. But in this case, you have to consume more amount of concrete. But depends on your case. Uh, Depending and based on your cases, you have to select one of them. Anyway, in any element in structure, I'm talking about the main concept of any design in your life as an engineer. You have load and you have capacity. Okay, what does it mean? That means this is your loading, and you have to provide something. You have to provide something, for example, your beam, your column, your foundation, your braces, whatever. This element should provide the adequate capacity against this load, to resist this load. For example, you want to design a wall, or let me say it in this way. This is your room. Okay, this is your room. You want to design these walls. For example, here on this roof, you assume that depends on your experience. Sometimes, for example, the weight of the roof itself, for example, is 500 kilogram, and sometimes some people uh, might be on this roof. Okay, for example, in the worst case scenario, you might have 10 people, 10 persons on this roof, and you assume that each person has the weight of 75 kilogram. So the total weight in the maximum case, in the worst case, could be about 750 kilogram. Okay, and as I said, the weight of the roof itself is 500. So what is your total load? 1,250 kilogram. Okay, this is your maximum load. This is your maximum load because of because of different elements, because of different uh, situations. Some of them it's you can sometimes you have to assume the snow, the weight of the snow. You have to assume the weight of rain. You have to assume the weight of wind. You have to assume the load of earthquake generally. But here I just consider the weight of people and the weight of their roof. Anyway, so this is your load. Okay, and when you want to design this wall, you have to provide the thickness and the material of this wall in a way that this wall uh, be capable of uh, carry this load. For example, as I said, the total load is 1,250 kilogram. How many walls do you have? Four. So each wall should resist again, for example, something about uh, 275, for example. Okay, and so when you want to design your wall, you have to, as I said, provide the thickness. You have to provide the thickness and the materials, such as, for example, if you are using concrete, you have to provide strong enough concrete. If you're using bricks, you have to use adequate stiffness. You have to use adequate strength, strong bricks, whatever. So this is the main concept of design of anything. So if you design if you design this wall, you have to provide a wall with a capacity more than what? More than this. So your final capacity should be more than 275 kilogram. Okay. So, for example, if you want to design a wall, finally you design, for example, finally you design a wall with a capacity of 300 kilogram. So this one is reasonable. Why? Because the capacity is 300 and the maximum load is 275. Okay, so this one capacity is more than this one, and this is good. But if, for example, you design a wall with the capacity of 250 kilogram, this is the final capacity. In some cases, you'll have what? Collapse. Or in the other way, in the general way, failure. Okay, and this case is not good. We have the same concept in foundation engineering. So, for example, this is your building. Okay, this is your building. And for example, one, you have 10 tons of load here on this building. And these loads should finally uh, should transmit to the ground. So if everything be symmetric, you have 5 ton here and 5 ton here. Okay, so what would be the last force here? 5 ton. And as I said, for example, assume that we have isolated shallow foundation. In this case, you have a load with the magnitude of 5 ton and a foundation. As I said, uh, we at this course, because the foundation design is a part of RC, reinforced concrete design, not found in a foundation engineering. So at this case, we assume that this foundation is strong enough. Okay, we assume that it is assumed that the foundation has the required capacity to transmit the load. This is our main assumption. Okay, so when the load is passing through this foundation, we're not going to have any cracks, any failures, and this load will reach to the ground. Here is ground. Understood? So what we're gonna do here in foundation engineering, our our duty in foundation engineering is to check if this soil here, this ground here, is strong enough to resist against this force. So as I said, the capacity, uh, as I said, the main concern here in foundation engineering is to check if this soil has the required capacity for this load. We have uh, different failures or failures criteria. What does it mean? Suppose that you have, let me see if I can. Uh, okay, okay. Here I'm gonna show you this failure with another test. Suppose that you have a rod. Suppose that you have a rod here, okay, a bar, and you apply tension and tensile load at the both ends. What's gonna happen if you increase the load? If you increase the load, we'll have this situation. Here, because here we have the maximum load, we'll have some shape like this if you increase the load. Okay? And if you again increase the load, you'll have rupture. This is a failure. We call it failure. Let's see here. You can see that in this case, in this test, we are increasing the loads at both ends. As I said, by increasing the force, we'll have a shape like this. We call it neck or necking. And if we increase the force, finally, I don't know if you can see the picture. You can see that here we have a rupture. In this case, I mean, in the case of a steel rod, this is our failure. If you have, for example, a wall, and if you apply force, too much force, that means more than its capacity. For example, in the previous case, if you remember, I told you that the capacity. Suppose that you have 275 kilogram of force, and your capacity is 250 kilogram. This is your capacity. So what's going to happen if I apply a force with this magnitude? You have a failure. Depends on the element type. We have different uh, failures. For example, in this case, if I increase the case, I'll have crushing in this part of the wall. Okay, so the capacity is uh, uh, less than the applied force, and you'll have crushing. In this case, this is your failure. In another case, suppose that you have car, and for this car, you bought tires. Okay, if you check uh, the capacity of these tires, you'll see that, for example, these tires are for the maximum speed of, for example, 200 kilometer per hour. If you increase the speed, because the heat, the temperature inside these tires increases, and also because of the pressure, because everything, If you the company recommended that the maximum allowable speed is 200 kilometer per hour. What if you increase your speed to 300 kilometer per hour? What's gonna happen? Because of the increased heat, because of the increased pressure, you'll have what? Explosion. And this is the failure in here. So this is the failure when you are working with uh, tires. So each element has its own failure. What about the soil? Suppose that this is your foundation, uh, and you have a force here, P. Before using this foundation, before designing this foundation, as I said, this is a concrete element. And before applying this force, you have to check if the soil here below this foundation has the required capacity to resist against this foundation or resist against this load. In how can we find this? As I said, first of all, we need to know uh, the failure uh, criteria or the main failure type in the soil. Here you can see the main failure of the soil. Here we can see the main failure of the soil. What do you understand from this shape? Here you can see that if you increase the force, if you increase the force more than your capacity, if you increase the soil, if you increase the force more than the capacity of the soil, uh, beneath this foundation, below this foundation, you will have some separated surfaces like this, and the soil is split into different parts, and you're not going to have an integrated medium, an integrated soil anymore, and this is your failure. So as I said, for example, when you work with tires, the failure is explosion. When you work with uh, steel rod, the failure is rupture. When you work with uh, brick or masonry walls, the failure is crushing. And when you work with soil, the failure is like this. We call it failure surface of the soil. So if the soil, the capacity of the soil, for example, is uh, if the capacity of the soil is, I don't know, for example, 10 tons, and you apply uh, 12 tons below this foundation, you see something like this. And the soil is not stable, or it's uh, unstable. It's not stable anymore. Why it's not stable? Because here they're not connected together anymore in these parts. They'll slip. In here we'll have slippage. And finally, your structure, for example, will have such thing of your structure. Because what? Because this surface uh, slipped against the other one, and you have overturning. So the main task and the main concept of foundation engineering is first, find the capacity of the soil, the capacity of the soil, and then this is your first one, and second one, check if the capacity is more than applied load. Okay, so as I said, first of all, you have to find the capacity or the capacity of the soil. I mean the capacity of the soil means the point at which we have this failure. Okay, so for example, as I said, the point at which we have this type of failure is 10 ton. So if you are applying the force should be less than 10 ton, because if you reach this force 10 ton, uh, you'll see this failure. Understood? Afamehdi, Molly. Everything is
Yes, sir.
clear? Slavic, you hear me?
Yes, yes.
Okay. But but the capacity or the, before finding the capacity of the soul, we have to know that we have to answer this question.
Guys, can you see?
No, it's stuck.
Okay, sorry. We have to answer that. Uh, what are the terms that what are the terms that define the capacity of soil?
Teacher, we can see the screen.
Can you see it now?
Now, yes.
So, as I said, we have to answer the questions or the capacity of the soil depends on what? For example, if I ask you, for example, what are the components or what are the terms and items that define the capacity of or the compressive capacity of concrete. This is a concrete, for example, sample. Okay. If I ask you uh, the compressive capacity of or uh, where does the compressive capacity of concrete come from? So you have to say that. For example, we have aggregates and you have cement and water, and the compressive capacity comes from the interaction between cement paste and these aggregates. So because of the bond between aggregates and uh, cement paste. So this is the main reason for compressive capacity. Or for example, suppose that you have a wire. Okay, suppose that you have wire. I don't know uh, if you've seen the wires. There are lots of fabrics
Yes.
inside the wires. Okay, inside a cable. And for example, these cables, uh, these cables have high tensile capacity. Okay, if I ask you what is the reason of this high tensile capacity, you have to say that these wires, these fabrics. So in soil engineering, the capacity of the soil comes from three parts. Okay, comes from three parts. The first part is cohesion. The second part is the load above, and the third part is about soil below. Do you know what is cohesion or cohesion? I think you know it from the soil engineering, soil mechanics. Well, what is that? Cohesion.
What is it?
This one. What does it mean? Cohesion.
Cohesion means, how can I say it? Mm,
We can define the cohesion as the ability or how the particles of soils stick together.
yeah.
How the particles stick together. Okay, for example, if you check the sand near the sea, you'll see that it's not cohesive. But if you check clay, you see that it's highly cohesive. Okay. The other one, the load above. What does it mean? That means, for example, this is your surface, and you have a pile of I don't know, whatever, on the ground. Okay, you have a pile of, I don't know, for example, bricks or soil, whatever. This is your ground surface. So this load above the surface, for example, if you are designing a foundation like this is, you have to excavate a hole and construct your foundation, because the final level should be ground level. If you construct your building above the ground, your foundation above the ground, um, it's not gonna have a good looking. Whatever, you have to excavate, and then these parts are above the level. Okay, and if you have a bunch of, for example, water here, this also affects the foundation. And the soil below uh, the foundation. Okay, soil below the foundation. Why this is important for you? It's obvious, because this part is one of the most important, because you're constructing the foundation on the soil here. This is important. Also, uh, for example, if you have water, for example, the ground level water, uh, here, if you have water, the capacity of the soil is different from the case that you don't have water, whatever. So these three cases, these three items affect your final soil capacity. I'm going to talk about it in the next class. Okay, do you have any question?
Uh, Teacher, for the finding capacity,
Mm-hmm.
how we know that it's example 50 or 75? How we can know that?
50 or
How is
75 about
calculation?
what?
What's the main calculation for finding the capacity?
Here you mean capacity or what?
No, I know that it's the capacity the less than more than I know, but
For
how
the
we
cap,
find the capacity? The
I'll
wall
tell you.
example.
I'll tell you. You have formulations. You have relations. For example, here in soil engineering, you have thousands of formulations. Here you have to follow, for example, this formula. You have to follow this formula. If you use these formulations, you'll find the capacity. This is the, for example, in soil engineering, if you want to find the capacity of the soil, in some cases you have to use this. By using this one, you can get your capacity. If you're working with steel, you have different formulations. If you work with, for example, concrete, each case, each material has its own formulations. Researchers and uh, scientists uh, developed many formulations in the case that you want.
Teacher, we will teach formulation.
Yes, yes. In the next class or in the other one, I'll tell you.
Okay.
Okay, I'm gonna save this, and if you can download this, uh, that would be better, because I didn't know that it's gonna be dismissed after 20 days. Okay, see you next time.
Cheers.
See you soon.
See you.